Now, this is the second question in escape velocity. My name is Mr. Peck. Welcome to my channel. Okay, the data below are about the Earth and the planet Mercury. Okay, so here we have the radius and escape velocity for both planet, Earth and Mercury. We have their radius and escape velocity. Escape velocity is from the surface of the planet. Now, a pendulum oscillates with period 2 seconds on Earth. Okay, we have the pendulum oscillation here. Period. Talk about period. This pendulum should be on the Earth's surface, not in the space. The pendulum should oscillate on the surface of the Earth. Now, he said the pendulum, if the pendulum is on the planet of Mercury, that means the planet on the surface of the planet Mercury. So what would be the period of the pendulum? Okay, so he talked about changes of the period. The formula for period of pendulum oscillation is 2 pi square root L over G. So period depends on the length of pendulum and also the gravitational field strength of the planet. It depends only on two factors, length and gravitational field strength. Right? So like this is the pendulum, this is the length, and the pendulum, the weight is mass G, the weight mg. But the period does not depend on the mass. So if you have a bigger mass, the period of oscillation remain the same. The mass does not affect the period, but the gravity is. The gravity of the planet affect the period. So as we can see, we have Earth and Mercury on their surface. So both planets should have different gravity. The Earth should have bigger gravity than the Mercury because Earth is a bigger planet. It has a bigger gravity. So so the period should be different for both cases, right? Now, we need to invest because you see the pendulum for both cases the length should be the same. It doesn't talk about changes of length. The length should be the same. Only difference is the gravity because different planet, different gravity. So we need to investigate the value of the gravity before we can find period. Okay? So the formula for gravity is gm over r squared. Gm over r squared. So gravity depends on the mass of the planet. Yes, different mass, different planet, different mass. And also depend on the r, distance to the center. So they have different radius, should be different r also. And also escape velocity, the formula for escape velocity is square root 2 gm over r. So escape from the planet, so we use the mass of planet and radius of the planet. You escape from the surface of the planet, so use the radius of the planet. Okay, now we can start with the gravity. Okay, find the gravity before we can find period. Now we know that the pendulum is on the surface of both planets. So the distance is on the surface. On the surface, the distance is, just the, maybe I just draw out on the, on the surface, So yeah, on the surface, this is the radius of Earth. Okay. So now, on the surface, it is the r is radius of Earth, and the gravity is g. So use the formula. Okay. Ag equal to gm over r square. Because it is on the surface. Okay, this one use mass of Earth. This one use because you're on the surface, so distance is radius Earth. Yeah, like this one, radius of Earth, and the gravity is g. Okay, the gravity is g. This is for the Earth. Okay, so what do we have? We have here G, okay, GRE square, just cross multiply. So we get GM. And then, okay, then we go for this one. This one also apply the same formula, Gm over R square. So this is the mercury, so just use mass of mercury, and this is the radius of the mercury, G. So this is Gr mercury, and then this is G mass of mercury. Okay. All right, then we can apply the escape velocity formula and see. So for the Earth, escape velocity is equal to 2g mass of the Earth over the radius of the Earth, radius of the planet. So here we can substitute the gm become GRE square. Sorry, we have 2GRE square over RE. Okay, so we can cut off the radius of Earth. So yeah, so this is the escape velocity. Now so we can substitute the escape velocity. Yeah, we have the formula, the values. 11.18 kilometer per second. That means change to meter. Exponent 3. Okay, meter per second equal to 2g RE, radius of Earth. We have radius of Earth 6,400 kilometer. So this is 6400 exponent 3 again. So here we can find the gravity on the Earth, which is 9.765 meter per second square. So that is the gravity on Earth surface. Okay. Now for this one, also do the same thing and can find the gravity. Escape velocity to g mass of the mercury over radius of the mercury. Also substitute the GRE square. GM become 2GR mercury, and then so you can simplify, and this is the escape velocity. The escape velocity for mercury is 4.25. 4.25 exponent 3, and then square root g is we want to find g. Radius of the mercury is 2439. 2439. 2439 exponent 3. Yeah. So I can find the gravity on the mercury, which is 3.703 meter per second square. And this is on the surface of the mercury, gravity on the surface of mercury. So you see different gravity? Different gravity. The Earth has a bigger gravity than the mercury on the surface. So different gravity, different period. So now we can compare. And this one, the Earth period, yeah, use the formula period is 2 pi square root L over gravity Earth, and this is the period for mercury, 2 pi square root L over gravity of mercury, and this is 1 and this is 2. So what to do is 2 divided by 1, so period over Earth, and here 2 pi square root L over mercury, 2 pi square root L over Earth. Okay, and then we can cut off the comment. Yeah, we can cut off the comment. This one can cut off. Okay, so what do you get in the end? Here, GE go above and GM go below. So the Earth period just now, the Earth period is 2 seconds. So put in the 2-second period. And the gravity for Earth, oh yeah, we got the gravity already just now. Gravity of Earth, gravity for Mercury, put them all inside. 9.765 over 3.703. So we can get the period on the Mercury, which is 3.25 seconds. See? That's the answer. So on Earth, it oscillates with 2 seconds, but on Mercury, it oscillates with 3.25 seconds. That means on Mercury, it oscillates faster. No. On Earth, it oscillates faster, but in Mercury, it oscillates slower. Oscillate faster on Earth because it has very high gravity, 2 seconds only. But on Mercury, it oscillates with 3.25 seconds because it oscillates slower because it has smaller gravity. Okay, so the answer is this. Yeah, correct, 3.25. So that's the way how to do it. Yeah, see you in the next question.